Introduction. Geogrid can be categorized as geosynthetic material that widely used in civil engineering infrastructure projects, for example, ground improvement in railways. Geosynthetic material are frequently used in railway and road projects where ground improvement are needed due to existence of soft clays, loose sand, and high embankment. The geosynthetic application in this project is geogrid reinforced pipe embankment with individual pipe caps, where high-strength biaxial geogrid were intensively used in Malaysia's recently complete electrified high-speed railway project. For the problem statement, a high-speed railway project for train with speed of 160 until 180 km per hour was recently complete in Malaysia. The geotechnical design of the project required improvement of the existing foundation to sustain the imposed dead and traffic load for train speed of 160 until 180 km per hour. Ground improvement using geosynthetic in the project primarily such as geogrid reinforced pipe embankment with individual pipe cap is needed owing to the soil encountered in the project site were highly variable mixture of very soft silt and clays as well as loose sand. For the objective, geogrid reinforced pipe embankment with individual pipe caps were particularly and intensively implemented at various locations along the railway line and bridge transitions. The objective of the geogrid reinforced pipe embankment with individual pipe caps are: the first one is to ensure the adequate performance of the embankment in terms of settlement and slope stability. Second, to allow for embankment to be constructed rapidly, eliminate the effect of settlement and stability problem in terms of piling solution, and provide a load transfer platform in terms of transferring the embankment load through the pile to the dense underlying formation below. And the last one is to provide safe and cost-effective solution to the geotechnical engineering challenge encountered.
My name is Fairuz Nadzmie, so I will explain about the application of geogrid reinforced embankment. So due to the increment of the traffic volume, has significantly increased the usage of the geogrid in the construction project related to the highway and the railway. So as for the geogrid itself, it is known that it is a polymeric structure consisting of the regular open network which known to be connected tensile element. So the geogrid can be manufactured from the various polymers such as PET, HDPE, PVA, and etc. So the function and the use of the geogrid itself is to provide improving the performance of the pipe embankment in the railway and the highway construction. Geogrid in the pipe embankment can be in the form of the single or multiple layer and will be placed and installed above the pile. So the application of the geogrid is to increase the load transfer to the pile and also reduce the effect of the settlement. The multiple layer of the geogrid often refer to the load transfer platform where can increase the bearing capacity and also enhance the strength of the composite soil. Moreover, the implementation of the geogrid reinforced pipe embankment in the railway track can enhance the stability and also reduce the settlement. There are several advantages of the geogrid reinforced embankment. So for the first one is the finished construction work allow traffic to start immediately. There is no consolidation time required and also no need of the additional soil to help the consolidation, and there will be minimal effect to the environment. And also the geogrid itself will act as a reinforcement to help the absorb the stress during the construction and preventing the lateral movement of the soil. For the design criteria, the geogrid should be implemented the serviceability limit step or SLS, and also the ultimate limit state ULS for future prediction and load in the construction work for the railway and highway.
Hello, my name is Muhammad Yusri bin Yusof, and I would like to present about the design and analysis based on this case study. Geogrid reinforced pile embankment with individual pile caps were planned and constructed in this project for usage along the railway track and rail bridge approach transition for embankment 4 to 8 meter high. The application of geogrid reinforced pile embankment is to ensure there was no sudden change in settlement profile. The design is to reduce lateral pressure on bridge abutment pile and eliminate settlement between the adjacent ground and the bridge of hard point. This table shows the pile properties, which is the type of pile that we use is RC grade 45 with dimension 250 x 250. The length range which is 12 meter to 36 meter. This table shows the biaxial geogrid design properties with traffic load 30 kN per meter square, the friction angle 30 degree, maximum allowable strength 6%, and geogrid strength which is 400 kN per meter for machine direction and 200 kN per meter for cross direction. This table shows the conclusion formula that we use in this case study, which is based on BS 8006. Based on this figure shows the geogrid reinforced embankment, which is in the railway line section, and this figure shows the geogrid reinforced embankment in the transition bridge section.
Hello, Assalamualaikum and hi. My name is Muhammad Afiq bin Zamri, and for the result and the discussion, the result show that the tension of requirement of the geogrid is greater than the ultimate limit state than in the serviceability limit state as predicted. This reinforced pile embankment design solution offer a gentle transition from bridge to embankment and corrected that the settlement profile did not alter abruptly. The tensions needs in the geogrid appear to increase as the environment height increase. I think that's all for the discussion and result for me.
Okay, as a conclusion, it is a proof that application of geogrid can reinforce pile embankment with individual pile caps along the railway line and bridge. So actually this application of geosynthetic can ensure an adequate performance of the embankment in terms of settlement and also slope stability. Besides that, this application can allow the variation of subgrade stiffness, and also this usage of geosynthetic in railway application can provide safety and also cost effective. Actually, this application of geosynthetic can be compared with conventional method, which is sandfill, and this sandfill method will produce a higher risk due to damage nearby underground infrastructure, uncertainty of post-construction settlement, and also embankment failure during stage construction. Besides that, sandfills also needs more space during construction that could damage the transport routes and also the compromise of safety. So in terms of cost, sandfill actually consume higher cost, especially on the maintenance compared to the pile embankment.